we create, actually not create, we design a converter throughout the Logician software that binary to BCD converter, right? 4-bit binary to BCD converter we created, right? So today, what we are going to do is, so I hope you can remember that one in the last previous session, we talk about the binary to BCD to gray code conversion. So today we are going to design that converter throughout the Logician software. So before doing that one, I'm going to first convert that one. So for that one, first let me confirm one thing. Can you all hear my voice? Can anyone confirm me whether it's here or not?
Yes, ma'am.
Yes, ma'am.
Okay, okay, thank you. So this is going to be BCD, then we are going to convert it as a gray code. So no, I don't have. Let's see, okay. Someone requesting something. Issue. So BCD to gray code in the sense what? So BCD normally same as decimal up to 0 to 9, right? So now today we are going to convert that as BCD to grade. So anyhow, in designing of converters, whatever the source system is there, that means from where you need to convert that one to which system. Means this is going to be, if we are going to design a converter for BCD to gray, then it is starting from here, right? It is starting from here and the destination is this one. Okay. So in this case, we need to consider about the input and outputs. So now you are going to convert BCD system to gray code system. So the destination is what? Can anyone say the destination? So this is the starting point. BCD is our starting point. So from BCD to, it is going to happen from BCD to gray. So BCD is considered as the input source. Okay. This is the source system and the destination is gray. So that is going to be our output. Okay. So in here, rather than getting like this way, I will take it as this way. So today I'm going to 3-bit convert. Okay, so 3-bit in the sense for the binary I am considering only 3-bit. Okay, so this is going to be the 3rd bit, and I will take the same for I will take the same for this one as well. So I will keep this one. I think it's easier. BCD, this is going to be my BCD, and this is going to be my gray. So this will be my decimal. Okay. Okay. So this is also like this way. So in here you can see I'm going to design a 3-bit converter. Okay, so 3 bits are available. Then here also 3-bit. And I will take another one from here and I will mention it as here binary. So I will take it as B2, here B1, and here B0. In here I will take it as G2, G1, then after G0. So likewise I am getting. So I am considering 3-bit. So how can I decide that one? How many 0, 1 should be there? So 3 bits mean 2 to the power 3, right? 2 to the power 3. 2 to the power 3, right? 3 bits. So 2 to the power 3. 2 to the power 3 means 8, right? So we have to consider 8 decimal values. Okay. So here I am taking as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that correct? 2 to the power 3 means 8. So I have to take only the 8 numbers. So is it correct now? 8 in the sense it should be stopped from 7 onward, right? So I will remove these things. We don't need that part. Okay. So we'll just a little bit. Okay. Now it should be 0, 0, 0, 0. Then after 1, 1, 1, 1. Then again 0, 0, 1, 1, 0, 0, 1, 1. Then after 0, 1. We can get this as a copy of this one. Copy and copy. Okay. Fine. So now gray code is what? We already know that if we are going to convert BCD code into gray code, then first digit should be as the same way, right? This one come as the same way to this place. So 0. Then we are considering XOR between these two. So 0 XOR 0 means 0. Okay. So then after we are considering this one with this one. 0 into XOR 0, 0. Okay. Then after same as this one. The first digit come as the same way, 0. Then 0 into 0, 0. I'm just revising these things, okay? Then 0, 1 means 1. Then after, keep the same one, 0. Then after, 0, 1 means 1. Then 1, 0 means 1. Okay. So likewise, 0, 1. Then after 0, 1, 1. Then after, tell me these things now. Okay. So here, first digit should be 0 because it need to put the same digit in here. Then 0, 1 means we are considering XOR for here. 0, 1 means 1. Then 1, 1 means 0. Then again first digit should be come as we can see. So then after second one, 1 0 means 1, 0 0 means 0. Then after first digit come as same way. 1 0 means 1, 0 0 means 1. Then after here also same, here also same. Okay, so here one good. So 1 1 means 0, 1 0 means 1. So here put in the same one here. 1 1 means 0, 1 1 means 0. So this is the gray code output throughout the BCD one. So this is going to be the conversion of BCD to gray. Okay. So some answers are there. Yeah. Yeah. So 42, you've given the answer, right? 69 also, and the 7. Thank you for your answers. So then after, now we are going to generate the equation throughout this truth table to design the converter for BCD to gray code. Okay. So in here, we are considering these lines. We are considering this one as a separate one, then this one as another separate one. We will put this one and this one as another separate one. Okay. So one by one we can consider and generate the equation for each of them. Okay. So here we are considering only the min terms from here. Just you can see that in here 4 zeros are there, 4 ones are there. Then here 4 0, again 4 ones. Here also same. So min terms in the sense what? If we are considering the min terms, then we are generating our equation throughout SOP method. Did you get my point? So here we are considering the min terms. Min terms, okay? So min terms in the sense we are generating the SOP equation throughout the SOP method. Okay. Min terms, we are considering the min terms and generating the equation throughout the SOP method. Okay. If just assume that here 0, 0, no. Here 1. Here these 3 also 1. Only 1 0 is there. At that case, we can consider POS rather than considering the SOP. Because rather than considering more ones, it's better to consider zeros, right? So POS. If it is min terms, we can consider it as a SOP equation and generate SOP equation. If there are max terms, then we can consider it as a POS one and we can do the things. Okay. So I hope so now we are going to generate G2 equation. Okay. Okay, so we are going to generate the equation for this one. So G2 is this one, right? So we are going to consider this one, G2. So you can see 4 ones are available. So we'll remove this one to here. Just get it here, right? Otherwise it is here. Disturbance for us. Okay. So here you can see 1, here 1. So we are considering this one. So I will put it as this color. So here B B2 B2, okay, B2, then after this should be 0 0. So B2 dot and B1 bar B0. Okay, then after here again B2, then after B1 dash, then B0, here B0 dash, right? Okay, now here B2, B1, B0 dash. Then here B2, B1, B0. Dash is not there. Check that one, is it correct or not? B2, B1 dash, B0 dash. B2, B1 dash, B0. No. B2, B1, B0 dash. B2, B1, B0. Okay. So these are the things that we have to consider for our generating equation for the B2. Sample input here plus, because we are going to consider the post method, not post method, right? SOAP method. This one. I think you can understand that one, right? Other than that, we can simply taking it as ABC. That one also possible, okay? So who are there? This one is there. Okay, now G1. So G1 is this one, right? So this is going to be, yeah, this is going to be our G1 thing. So we can just remove these things. And here we are going to get the G2, G1. So this one is considered in this one. So B2 dash, B1, B0 dash, B2 dash, B1, B0 dash. This is this one. So then after this is also one. So first one is dash, other two is normal. Okay. So then after here, first one is normal, other two are dash. So then after this one, then B2, B1, dash, B0. Dash is not. Okay, only here it should be dash. Then after here not dash, here should be dash, here not. Fine. This is our this is the G1 equation. So plus so for this one, one also should be there. Okay, so now our G1 also fine. Now it's time to G0. Okay, so tell me that one. So we are considering this one. This one and this one. Lastly, this one and this one. So you can directly type in here. So this one is B2 and B1 dash, and last one is no dash. B2 dash, B1 dash, B0 plus. Then this one, middle one is normal, the two dash. No, middle one is the Middle one is normal. Other two is dash, right? Am I correct? Take that one. Then after here, middle one is dash. Now it's same as this one. So we can take a copy of this one. Then one should be dash, other two should be normal. Now the last one is same thing, but last one should be okay. So these are the three equations that we are already generated throughout this truth table. Okay. So we are considering this G2, G1, G0, and we are going to create the logicing equation for that one. Logicing design for that one. Okay. So some of you have power cut issue and the things, right? Because of the rainy situation. I think in this case I can't do anything for that one, but what I can do is I can request sir to give the recording for you. That's it. Actually, recordings are not with me also. So you can request recordings from sir for them. Okay. Okay, no issue. So this is going to be our three equations. So we will take it to here. Yeah. This is too short. Okay. So according to this question, first we are going to create G01. So we need three inputs for here. So I will take so we will take this one here. Okay, so we'll create numbers as B0, G1, then D2. Okay. Now, according to this one, we need OR gate and also AND gate. First, we need AND gate, right? So, the next one, AND gate. So, I will take this one to here, little bit. Okay, so I need three input, right? Here, 1, 2, 3. Three input AND gate. So, I need to select that one and three input. Then it comes from this side, right? So I need to rotate that one. So did you see that one? It's better to check another one. Yeah, okay. Okay, so first one said that our equation is G0. So output should be, see, you are not telling anything to me, right? It should be not G0, it should be B0, right? So I think you are not hearing my voice, right? Otherwise, you are telling other day, other days you are telling that, right? It should be B. It's not B G. Likewise, you are telling, right? So we are generating gray code converter throughout binary code, BCD code. So input should be BCD, output should be gray code. Okay, so that's why I changed that one. Okay, so here first we need to check that one G1. So B2, B0 is going to be normal, and other two should be true outer and. So we were taking that one here, and we are taking same copy of here. Taking this much. Okay. Then the file. Why it is in red color? Because not connected, right? Now fine. Okay, now first one is done. Then second one is 2 and 0 is not. Then 2 and 0 is not. Others are normal. Other means 1 is normal, I think. Yes, 1 is normal. So we can take directly from here and come here. So 2 and 0 are should be not. So I will connect that one to here. And I can directly get this one to here. Fine, right? So that one also fine. Then after the next one. This one fine, this one fine, this one fine. So last one is no, the third one is B1 is dash, other two is normal. So B1 is here, directly from here. Then we can take it from this line to here and this one to here. Okay, so the last one B naught is dash. So B naught we can just directly from here. Before going to hit that one, we need to take the AND gate from here. Okay, so then after B naught is 0, other two is normal. So other two directly to here, other two here we can just take from here. Okay, so now 1, 2, 3, 4. 1, 2, 3, 4. Now G naught is 5. And this is going to be 4 input one. So this will become from this one. This will become from this one. And this will become from this one. And this one. So this is going to be the V naught output. Not V naught, G naught, right? I hope. Yes, G naught. Okay, so can you understand that one? Is there any issues related to up to now things?
No, ma'am.
Oh, okay. Thank you. 001 also said that is okay. So input is, see, we considering BCD as our source system, gray as our destination system. So it means BCD we are considering as inputs of our converter. Gray is considering as outputs of our converter. Okay. So keep in mind, the source code always should be, source system always should be considering as inputs. So the destination system always considering should be outputs. So according to this one, always inputs are B1, B2 and B0, B known, and the outputs are G1, G2 and G0. So according to this truth table, we generate the logic diagram for this G note 1. So this is the G note 1, G note logic diagram. So can you go try to generate this one? And let me know if there is any issue. I will put this one in. Yeah, it's better to put this one in here, right? We'll make little bit can visible, right? Okay. So I need answer from all of you. Just give a try to complete this logic circuit and let me know. So 35 you already completed, right? Okay. So I hope now you are familiar with the Logisim items, right? Tools. So I think, yeah, 15 and 25 also completed, right? If you are working with me, it's good to hear. So, Galaxy, are you there? Or else Isuru?
Yes, ma'am.
Yeah. Shall we conduct the first year on coming Friday?
This week,
From,
ma'am.
yeah, this week Friday. Then it is easy for us also. Means from the basic things up to now things, not that much hard. I think it's better to conduct that one on Friday. What about others' opinion? Okay. So some of you are saying okay, right? Okay, so then up to now we complete basic logic circuit and also binary to BCD converter and BCD to gray converter. We already complete these things. Okay. So we can conduct the first CA on up to now these covered things on this week coming Friday. Okay. Keep in mind. So starting from 2, right? I think starting from 2. Yeah. Okay. So we will do like that way. No issue. Then we complete that one. Okay. I will tell rest of the part before the end of this session. Okay, so 42 is also send the screenshot. 38. Then was this 002, 64. Then 76, 96. And yes, thank you for your answers. Finally, the 55 and the 80, right? Okay, thank you all of your answers. And 84 also there. Okay, so okay, Alexi, then we will do accordingly. So this Friday, then okay, then this Friday we will complete the converter part. Then next week, Wednesday, you will have the first year. Is it okay for all now, right? So next week, Wednesday means I think, yeah, 20. 20, you will have the first CA on this subject, okay? Keep in mind. No issue. Okay, so lots of you send the screenshots. Shantika also sent 72 also there, 56 also there, 81 also there. Okay. So thank you for all of your answers. So now we are going to move to the next part. So here, I hope you can see my screen. So here we are generating the equations for this one, right? So you can see one thing. If we are going to generate the logic logic circuit throughout this equation that are just generated throughout by considering these ones, it will be somewhat big, right? Can you see that one? See, this kind of one will come for G1, G0. Then how about this one? G1 and G2. So also same for this one, right? This kind of one will become after this one. Again, this kind of one. So circuit will be little bit big for this one. So there's a solution for that one. What is the solution for that one? Can anyone tell? To reduce the size of the equation, logic software, logic circuit, what we can do? So passing also send the output, right? Yeah, K-map. K-map is the only one solution for that one. No, there are some solution as well that we can do the yeah, the easiest way is K-map, right? So now we are going to put the K-map for this one. So I will take this one for my K-map purpose. Other than that, it is going to somewhat difficult to draw that one, right? So we need 4x2 one, right? So there's 2, 4, then this is the last one. This is my last one. So this is going to be A and here BC. So we just consider this as ABC because other than that, I have to write it as, I will take it as A, B, or is no need. No need. We will write as we can see. Okay, so I will write it as B2 and here B1 and B note. Okay. So then after here as the same way, I will just change the color into black. So here what we have to do, 0, 0. At once we can change one digit. So 1, 1, 1, 1, 0. Am I correct? That's right. So here 0 and 1. Now, this is going to be our G2. This is throughout this K map, we are getting the output equation for G2. Okay, so we are considering these four. Okay, these four are in. So if we are putting, we'll take in color. So if we are putting 0, 1, 3, 2, then after 4, 5, 7, 6. Okay, you can remember that one, right? So I will take blue color. Now, this 1, 1, 1, 1 in 4, 5, 6, 7. So 1, 1, 1, 1, 4, 5, 6, 7. All others are 0. Okay, so I'm going to group this one. I will use which color? All colors are used. Okay, so I'm going to group this one. So this is my group. So I'm generating the equation throughout this one, considering this one. This side we can't consider, right? Because all are 1. But this side we can consider, right? So 0, 1. 1, right? So we are considering this one. And equation is B2, not dashed, just B2. So throughout this G2, we are generating our output as B2. So equation is B2 for G2. Then, now we are going to generate the equation for G1. Okay. So G1 is what? This one, right? So same as this one, we need 4 into 2 map. Then after here also B1, B0, B2. Then after I will change the color to black for this one. So I think you don't need to write it again. 1, 1, 1, 0, then 0, 1. Okay. So I will get blue color one. So just assume that 0, 1, 3, 2, and 4, 5, 6, 7. Okay. So now you can see we are considering this line for G1. So this is for G1. So we are putting 1, 4, 2, 3, 4, 5. 2, 3, 4, 5. So one side, these places, others are 0. So this is going to be 0, this is going to be 0. So now we are going to group this one. So this is going to be a 1 group, and this is going to be 1 group. Most clearly, so this one is what? This one is what? Can anyone say? These two, B2 dash is common, right? And B1 is common. So B2 dash B1 is a common. Then also what about this one? This one again B2 common. This one here is B2. In here B1 is common, but it should be dash, right? So throughout these two, our our equation is B2 dash B1 plus B2 B dash. Am I correct?
Okay, here you can see, we can change the animation of the transfer. Okay.
So here it should be not this one, right? No. Here it should be. Okay, it should be one. Okay, okay, one, not the dash. Okay, so B2 dash B1 plus B2 B yeah, one. Okay, two. Okay. Now is it fine? Yes, 41. That's the correct answer. If we can see this kind of one, if we can see this kind of one, definitely we can put the XOR for this one. You can see B2 dash B1 plus B2 B1 dash. So directly we can get that as B2 XOR B1. So this is going to be the which one? G1 output. G1 equation. So this is the G2 equation. This is the G1 equation. So now we are going to create the G not 1. So we will create that one here. 4 by 2 1. 4 by means this side 4 by. Why you are telling that? Why you are not telling that to me? Okay, now fine, right? Okay, so here 0 0 0 1 1 1 1 0. So here 0 1. Then we can put it a little bit here. Then the color is going to be like this way. So here B2 and B1 and B0. Then after we are going to put the values for this one. So we are considering these two. So it is in 1, 2 and 5, 6. So 0, 1, 3, 2. So here one should be there, one should be there. Then after 5 and 6. So 5 and 6 in here. 5, 6. Okay. So now we are going to group these two. This is going to be 1. This is going to be 1. So all these are 0, 0 and 0. So what about this one? Tell me the answer. Can anyone tell the answer? No, I'm not sure. Yeah, definitely. So throughout this one, our answer is what? So this is not common. So this one is common. So B1 not B0. So this one is again coming B1 B0 dash. So you can see that throughout those two parts, we can see the same thing like this way, right? So we can just directly get it as B1 XOR B0. Yeah, definitely. So 74, 38, and 1 and 41. Thank you for your answers. Okay, that's the correct answer. So now we take that one as B1 and yeah, B2 plus. So we note down that one. So this is going to be the final one. So B2 plus, then after what? B2 X all. Okay, tell me that one. Okay. So now this is going to be a little bit big one if we are not going to do that one by using ornaments. Okay. So I'm going to delete those things. I'm going to just delete those things. Okay. So here, according to this one, I need 1, 2, 3 ands, not ands, or then after AND gates. So I will take AND gates for here. Then I will make it as for this one. So here we can directly take this B2 as same as, right? For this one, this is one input, this is one input. 69, so good. So we will consider this as a B2, then this one as B1, and this one as B0. Then after, we need a OR gate for here with 3 input one. So we can directly take that into this place. Then after output is going to be this one. So then after B1 is, no, the second one is B2 XOR B1, right? So XOR, we need a XOR gate. XOR gate, yes, this one. So we don't need this one. We need XOR gate and it should be 2 input one. So keep in mind, these things keep in mind. So we need the XOR with so for G1, what B2 and B1. B1, then this is going to be the input for this one also. So we need the same for here as well. Then after we have to consider B1 and B0. We can just B1 and B0. Just connect this one. Finally, to this one. Okay, so this is the final logic circuit for the this BCD to Gray converter. Okay, so you can see this thing. Rather than using two more logic circuit, sub-logic circuit, we can directly use this XOR gate and we can reduce the size of our logic circuit, right? So this is the final output of our converter. So we can check that one. Now at the initial step, so this is going to be here. Yeah, I did a mistake. Why I combine all these things? Will be here. Will be here. Because this is going to be 3-bit converter, right? Or 3 bits separately. Okay. Now we can see the first one is 0, 0, 0. So initial step, it is going to be 0, right? B2 is 0, B1 is 0, B0 is also 0. Now answer is also G0. This is going to be G0. So we will put that one as well. Otherwise it will G2, G1. This is going to be G1. Okay. So fine. Now answer is also 0, 0, 0. Let's reduce the mark size of this one. Okay, so now the second one is 0, 0, 1. So third one should be 1. B1 should be 1. So answer is what? 0, 0, 1. You can check that out. 0, 0, 1. Okay, now this one 0, 1, 0. So 0, 1, 0. So answer should be 0, 1, 1. Answer should be 0, 1, 1. Correct, right? So then after third one, 0, 1, 1. 0, 1, 1. So answer should be 0, 1, 0. 0, 1, 0. Okay. It's also correct, right? So this one, 1, 0, 0. I said 1, 0, 0. 1, 0, 0. So answer is 1, 1, 0. Answer is 1, 1, 0. Correct, right? So you can see that throughout this truth table, first we need to generate the truth table for, we have to do the conversion for the BCD and gray one. Okay, then after throughout the truth table, we are generating the equation. For the E sequence, we are using KMF for generating the equation part. So now by using the KMap, we are generating 3 equations. Throughout that one, finally we create this converter, 3-bit converter. This is called 3-bit BCD to gray code converter. Okay, this is what we done so far. Okay, so did you understand that one? Is there any problems with this? Have you all got that one? Okay. So what about others? 44 and 15 and 69. So good. Okay. Yes, right. Is there any problems? Okay. So then, shall I give a one question for you? Okay. So what about others? Always answering those people that 138 and 15. 200 also, yeah. Same people answering again. Then what about others? Okay, I will give one task. Okay, let us see who can do that one. Okay. Okay, just do you need to take notes of this one? Shall I give 5 minutes for that one? Yeah, someone is asking that why I designed that logic circuit before drawing the K-map. The reason is I want to show you that without K-map, the logic diagram is going to complex rather than we expect. So you can see we can directly design the logic circuit for this BCD to gray converter after using this K-map, right? So that's how we have to minimize the equations of the converter throughout the K-map. Other than that, that one is going to be complex. Not little bit actually, so much complex. So if we are going to use K-map and reduce the size of the equation, then it will be easy like this way. So that's what I need to show you. That's why I said previously I designed the logic circuit for that G1 separately. Then after I will put the K-map method and I reduce the size of the equations. And now finally I got the output as this way. So I want to show you that one, okay? Okay, sure. I will show that one as well. Before the one, so for that, so there is going to be this one. Um, yeah, who's that? 23. Is it okay without doing those things without this XOR? But you can understand that, right? Rather than using these two, means these two, we can directly use this one, right? So if we are not going to use this X or 1, definitely we have to use 2 and get for here, right? So I think it's useless thing. Rather than using 2 and gates for the same thing, we can just directly use XOR, okay? So keep in mind. So the thing is, you have to keep remember that Boolean rules are there, right? If you can remember those Boolean rules, then you can easily build up all these equation at the same time logic circuits. Okay. So once you're done, please let me know. And at the same time, if there is any issue related to this BCD to gray conversion part, you can ask, okay? Okay, so hope all of you done that one. Can anyone confirm me whether you done or not? So one said that completed. What about others? I got two, one, one, two, three, four, five, six, seven. Seven outputs. Now wait. What about others? Still I got eight outputs. What about others? Forty-one answers there. 38 answers there. Then appears 25, 93, 80, 15, 84, 69. So, what to do, right? Someone asking what to do, right? So, I just need to try this one by yourself. Okay, so 76, 56, 35. I'm always thinking that you are working with me. So when I stop the explanation part, you have to do that one, okay? So that's how we are doing, right? Okay, so 23 already done. Okay, thank you for your answer. Okay, so let's move to the next part then. Okay, so I will, okay, 86, okay. Thank you for your answer as well. So I can see the same registration numbers again and again in the chat. So what about others? Now I can remember those registration numbers. That much they are putting the screenshots. Always putting the screenshots. I don't know what about others. Hi guys, they are in the session or not? I will tell one thing in the end of the session, okay? Okay, 33. So 96 one also there. Okay. Okay. Let me do one thing. Okay. So now up to now what we have completed. Now previously we created binary to BCD convert. Okay. So now today we created BCD to gray code converter. Okay. So what I need to do by yourself. Okay, 96 and 42 answers are there. Fine. 81, 101. Okay, okay. Thank you for your answers. Okay, now. um, okay. So, so shall I erase this one? It's better to erase, right? Okay, let me erase this one first. Fine. Okay. Now, tell me that how we can convert gray code to binary. Just assume that this is going to be binary. Assume that this is will be BCD. So, if this is going to be the gray code, then we are writing the same one in here. Then we are XOR on this one. Then 1 XOR 0. Then again this one to this one. 0 1 XOR 1. Then to this one XOR 1 0 1. So this is the BCD one. This is the gray code. Now what I need to do by yourself is you just need to create a converter logic circuit for gray code to BCD code. Did you get my point? So what I need to do, 3-bit, 3-bit gray code to BCD code converter. So this is the task for yourself. Complete this one and let me know. What I need is you have to create a logic circuit for 3-bit gray code to BCD code converter. So now you know how to convert gray code into BCD. Same way you have to first fill out the truth table. Then after throughout the truth table, you have to generate the equation. Then after for the equation generating purpose, you have to use the K-map. Now you know how to use in the K-map. So what you have to do is you have to generate first, okay, no need to think about the logic circuit. First generate the table for truth table for that one, this one, and send me the screenshot of that truth table. You can use either, just it's better to use Excel sheet, okay? So use the Excel sheet and convert this and let me know the answer. We are going to create a 3-bit gray code to BCD code converter. Gray code to BCD code converter. Previously we generate what? 3-bit BCD to gray code converter. So now your task is to create gray code to BCD converter. You know how to convert gray code into BCD. So now you know how to create a truth table. So then after throughout the truth table, you have to generate the equation by using the K-map. Then finally come to the Logician software and throughout the logic tools, you can generate the logic circuit. Do this one. I need the answer from all of you. At the same time, if you have any issue, please ask, okay? Okay, 79. So your answer is there, right? Okay, thank you for your answer as well. So just assume that I will make it easy for you. I will make it as binary. Then it will be a bit easy for you to think. We will put text in here. In this way. Okay. I will put it as binary. What happened? Why? Okay, okay, no issue, no issue. I will try to take it. No issue. So I had to save it. Grey code to binary code converter. So this is the task, okay? Think it will be easy for you. Let us see how you are going to do that one, okay? Okay, so first 41 you already sent the answer, right? Okay, so yeah, that one also okay. Because BCD binary is going to be same, right? So no issue. So up to 0 to 9 it little bit same. Okay, so once you've done the truth table, first send me the truth table, a screenshot of the truth table. Then after you can go for the circuit design part. No, before that one you have to generate the equation first throughout the Kano map. Then after go for this circuit generation part, okay? Okay, 35 answer also there. Okay, 83 also done. Okay, so good. So what about others? Already 3 guys completed. So 83 was 35 and 41. You can start the generating equations part. Okay, 25. You also can start the equation part. Once you done the equation part, then start the circuit generation part. Then once completed, send me the screenshot of the circuit diagram, okay? The code converter, gray code to BCD. Okay, 30, you also done, right? Yeah, you also can start, but 30, you completed that BCD to gray, right? I asked you to I asked you to create gray to BCD. Did you get my point? 30, I think 30, right? Dinuka, right? Okay, so what about others? Yeah. So 93, you can start the equation part. Then 42, you also can start the equation part. What about 27? Yeah, 27. You also can start 86, 76, 101. You can start the equation part and send me the screenshot of the Logisim software that you already created. the circuit for that one. So now I can see the 79 answers also, right? So now I am familiar with these registration numbers. Okay, 72 also there. Okay, 23, you also can start the equation part. 107, you also can start. So what about others? Are you doing no? Is there any issue? No, 107. What is this? 002. Yeah, you also can start the equation part. And I am waiting for your logic circuit. Okay, so 15, you also start the logic circuit part. And 39 also done, right? So now I can see this 99 paper. 69 is always there. 39 also and 79. What about the 49 and this 49, 29, 59? What about these guys? Okay, so 23, no issue. If you can generate for bit one, no issue. So 91, I saw your registration number now, right? Okay, so your answer is okay, fine. Yes. Okay, so what about this second one? 91, when you are getting logic that OR gate or NAND gate or XOR gate, please remember one thing, you have to fix the input according to your requirements. Okay, if you need only 3 inputs, then you have to customize that input number of input to according to your requirements. If you need 2, then customize that one to 2. Okay, so it's automatically coming when you are getting a gate throughout that Logisim software, it will automatically come as 5 inputs. So if you don't need 5 inputs, so please customize that edit throughout the edit properties. You can see that, right? So just assume that I'm going to take this XOR gate. So here it's coming, see, it's coming with 5 inputs. See, this place, there are 5 inputs available. So you can just click on here and make it as 2 or else 3 inputs. So only 2 can visible. Did you get my point? So it will be nice rather than okay. Rather than putting so much inputting here, okay? It will be nice. Okay. Okay, 19, so fine. Okay, 33, your answer also there. Mm. Mm. Okay, so I will send those output to screenshots. 38 and 1 answer so there. So if you are done with the truth table part, throughout the truth table, you have to generate the equation for that one by using K-map. I already told in the BCD to gray code converter part. So as the same way, you can do the same thing and you can generate the equation throughout the truth table by using the K-map. Okay. 38, did you get my point? Then after you have to create the logic circuit for that converter. Okay, so is this 002 you also done, right? Okay, What about others? Okay, so 23 also. Okay, 23. So 86 also done, right? So those who complete, let me confirm one thing. Did you all get up to know things? Gray code, BCD code, BCD to gray, gray to BCD, then binary to BCD. Did you all get my points? Okay, thank you. 93 and 80 answer also there, right? Okay, 85 answer also there. Actually, you are doing well, right? Most of the students are engaged with the session, right? So 85 also there, 81 also there. So thank you for all of your answers. 35 also there. So I think time is almost 3:40, right? We have the session 1:30 to 3:30. So first I will stop this one.
Recording stopped.
Okay. So I need confirmation from you for the Wednesday CA. Shall I put up to this gray code part or else? Shall I put the Friday part as well? What about your opinion? Your preference? Okay. Option 1 is put up to today's gray code part. Option 2 is Wednesday newly added part also will be there. What will be your preference? 1 or 2? Option 1. Okay. Okay. So most of you guys are saying that option 1. So I will option 2. Okay, 1 is telling that option 2. Right, 1, 2, 3, 4, 5, 6. 6 guys are telling that 1, only 1 telling that. Oh, so majority is 1, so we will take option 1. So your upcoming Wednesday, first CA will be cover up the things